All right, today we're going to look at section 1.5, which is complex numbers, or the i's, the imaginary numbers, as you guys like to call them. We're going to add, subtract, multiply, and divide them, and then find complex solutions to quadratic equations, so we can have negatives under our square root now. So we'll start with just imaginary numbers and the definition. So the imaginary number unit I, which we all have dealt with, I is the square root of -1, and I squared equals -1. Two things that you will need to know to simplify in college algebra. So we'll start just by simplifying some square roots. So if I have the square root of -5, so remember that I equals the square root of -1. So this could very simple be the square root of -1 times 5. The square root of -1 is I, so you pull out the I, and it's I radical 5. And then part B, we have a negative square root of -19. This negative on the outside stays on the outside. Negative on the inside becomes an I, and I can't do anything. The 19 can't simplify, so negative I radical 19. Anytime there's a negative underneath the square root, it just means we pull out an I. So this one, again, I have a negative on the outside, it stays. I have a negative on the inside, that's an I. And the square root of 81 is 9. So we would, write this as -9i. The I is always written after the number, not before. Here I have the square root of -12. So again, we're going to bring out the I, and I have the square root of 12. We need to simplify 12. 4 times 3, so this would be the square root of 4 is 2. So this would be 2i radical 3. So remember the 2, then the I, and then the radical. Don't put the I after the radical. It makes it look like it's underneath it sometimes, and it could be counted off. So then we get into complex numbers. So a complex number is the form a plus bi or a minus bi. A and B are real numbers. A is going to be the real part, and B is the imaginary part of our number because B is with the I. So when we deal with complex numbers, we have two different kinds. We can have a regular imaginary number where we have our a plus bi, where a and b are not 0. Not sure what this little a is right here. We can ignore that. A pure imaginary number is a plus bi, where a equals 0. So a pure imaginary number would just be like 7i or -6i. It doesn't have any of the real part added or subtracted to it. So we're going to first look at adding and subtracting. These are pretty simple. All of our rules for the associative, commutative, and distributive laws apply, and it's just going to be combining like terms. So just like we were adding and subtracting polynomials, we combine like terms. We'll do the same thing here. So I have 9 plus 5i plus 2 plus 4i. So 9 plus 2 is 11, and 5i plus 4i is 9i, and we're done. Same thing, part B over here, we're subtracting. Remember when we're subtracting, we change it to addition and change our signs. So now we have 6 plus -4, which is 2, and 7i plus 3i is 10i. One more like this. Again, we have some subtraction in here, so I have 3i minus, so change our minus to plus and change our signs. This one's also minus, change it to plus and change our signs. And combine like terms. Combine the real parts first. So I have 2 plus -2, so those just cancel. We don't write 0. So I have 3i minus 3i, those would cancel, which just leaves us with -5i as our answer. So adding and subtracting, just combine like terms. Next, we're going to look at multiplying and simplifying. So remember when we're simplifying that I squared equals -1 is what we'll need from the first slide here. So multiplying here, we're just going to distribute in our 4i. So this would be 4i times -2 is -8i. 4i times 3i would be plus 12i squared. But remember, I squared is -1, so this right here is -1, so this would be -8i minus 12. But you'll always be asked to write in what's called standard form. So standard form puts the real part first and the imaginary part second. So you have to write them in standard form. The college will count off if you don't have it in standard form. Part B, 7 minus 6i squared. Remember this is 7 minus 6i times 7 minus 6i. written it out twice. This is going to be foiling, just like when we were multiplying binomials. So 7 times 7 is 49. 7 times negative 6i is negative 42i. Again, negative 42i. And negative 6i times negative 6i is positive 36i squared. So combine like terms right here. So I have 49 minus 84i. But here, remember, I squared is negative 1, so this would be minus 36. Then I have to put together 49 minus 36, which is 13 minus 84i. And then our last one, part C right here, is just multiplying them out. So again, foiling, 1 times 1 is 1. 1 times negative 7i is negative 7i. 5i times 1 is 5i. 5i times a negative 7i is negative 35i squared. So combine our middle terms, negative 7i plus 5i is 1 minus 2i. This negative 35i squared is negative 1, remember, so that would change that to plus 35. Combine our like terms, 36 minus 2i. Remember to always write the I term last, the real part first, the imaginary part second for standard form. So there is multiplying. Next, we're going to look at complex conjugates, which is kind of like we've talked about conjugates with our radicals. We also have them with our i's. So a conjugate, if we have 8 plus bi, the conjugate is 8 minus bi. Remember, conjugates mean this middle changes. So if we have a plus bi and a minus bi, they're called complex conjugates. Complex just because they have an I in them. So the product, if we multiply two complex numbers and its conjugate together, we get just a whole number. So if we look at an example of that, we'll use it when we're dealing with dividing. So again, here we're going to multiply again. 4 times 4 is 16. 4 times 9, negative 36i. In the middle, I get positive 36i. And 9i times negative 9i would be negative 81i squared. So if you look in the middle right here, the same thing, different signs, so they cancel. So I have 16, and this minus 81i squared would become plus 81. Add those together, and we get 97. So whenever they're exactly the same numbers, but the opposite signs inside, so conjugates, you'll end up with just a number. This one's even easier. There's no plus or minus, so multiply the numbers together. 7 times negative 3 is negative 21. And then I squared is negative 1, so this would just be 21. So multiplying our conjugates together gives us a whole number. So we'll use this when we're dividing complex numbers. So when we're going to divide a plus bi over c plus di, we're going to multiply the numerator and the denominator by the complex conjugate of the denominator. This will be a test question every year, and you will have to show your work. So what that means is if I have a plus bi over c plus di, we're going to take that but multiply by the conjugate of the bottom. So we'd multiply by c minus di. And that will get rid of our complex number on the bottom. Since these are conjugates, we'll end up with a number on the bottom only with the imaginary on top. So let's look at some examples. We're going to divide, but then we also are going to have to write it in standard form. So here, multiply by the conjugate of the bottom, 1 plus 8i. We're going to do that on top and bottom, so we're going to have to multiply this out. So we're going to have 4 times 1 is 4. 4 times 8 is 32i. Inside would be minus 3i, and then negative 24i squared. All over on the bottom, 1 times 1 is 1. Then we would have our plus 8i, inside minus 8i, and then minus 64i squared. And we need to keep simplifying top and bottom. So top, I would have 4. If I put together my i's right here, it would give me plus 29i. And then the minus 24i squared would be plus 24. On bottom, the middle i's cancel, so I would have 1. This would turn into plus 64. So on top, if I combine like terms, 4 plus 24 is 28 plus 29i all over 65. You cannot leave it written like that. They will count off. You have to separate this out into 28 over 65 plus 29, should just be a plus sign, plus 29 over 65 I. This I needs to be beside it or on the top. Don't put it on the bottom of the fraction. If you don't separate this into standard form, it will count it wrong, and your assignment also will not accept it if it's not separated out. So make sure when you're dividing, you separate those out. Okay, complex solutions of quadratic equations. So now we're going to use our quadratic equation. It's just that we're going to have i's in our answer, or we're going to use any method, I guess I should say, of solving quadratic equation or extracting square roots. This first one just has x squared plus 4, so we'll use extracting square roots. X squared equals negative 4. Square root both sides, so we have our plus or minus here. So x would equal plus or minus. The negative means I have an I, and the square root of 4 is 2. So this would just be x equals plus or minus 2i. The next one, we have 3 terms, so we're going to use our quadratic formula. Remember your quadratic formula, x equals negative b plus or minus square root b squared minus 4ac all over 2a. So then if we are looking at this and we want to substitute in, remember our a is 3, our b is negative 2, and our c is 5. So plugging in, x would equal negative b. Our b is already negative, so 2 plus or minus square root negative 2 squared minus 4 times a times c all over 2 times our a. So now when we're working through and we need to simplify what's happening here. Sorry, getting a calculator to do my work inside the square root. So this is going to give us 2 plus or minus, then work on the inside of your square root sign here. You get negative 56 all over 6. So now we can have negatives because I know how to simplify this. This is going to be 2 plus or minus, and then we need to break down 56. We can break down 56 with 4 and 14. Remember the negative means I comes square root of 4, so this would be 2i radical 14 all over 6. And then we need to simplify because our 2, and our 6 are all divisible by 2, so this would be 1 plus or minus I radical 14 all over 6. Your homework, again, I think it's going to ask you to simplify it. You'd do 1 minus radical I 14 over 6, comma 1 plus. So you'd write it out on your homework. You would write it out as 1 minus I radical 14 over 6, comma 1 plus I radical 14 over 6. Okay, because your assignment's on WebAssign. They mean the same thing, 2 different ways to write it. All right, one last one we'll look at here, and then we're done. So again, here our A is 1, our B is 4, and our C is 5. So if we substitute in, that's going to give us negative 4 plus or minus the square root of 4 squared minus 4 times our A times our C all over 2 times our A. So this is negative 4 plus or minus. Simplify inside our square root. Gives us negative 8. Nope, that does not give us negative 8. It gives us negative 4. 16 minus 20 over 2. So this would be negative 4 plus or minus. This simplifies. Negative brings out an I. Square root of 4 is 2, so 2i over 2. And again, divide everything out. So this would be negative 2 plus or minus I. On your homework, when you put it in the computer, it would be negative 2 minus I, comma, negative 2 plus I. The I has to be written second or you will get them counted wrong. So make sure you're writing them in your standard form. Let me know if you have any questions. That is our assignment or our lesson for the day.